My name is Liz Boettner, and I'm a rising junior in the Mechanical Engineering Department at the University of Michigan. My research this summer is comparing two velocity estimation methods. Using a laser rangefinder and an iRobot Create, like the one I have here, I acquired data to determine the more robust of the two estimation methods. The first method is the velocity tester method, a LabVIEW program developed by Rachel Biss. This method uses the collected data and creates a Cartesian grid representing the level of certainty a space is occupied by an object. By clustering occupied spaces and locating the center of certainty, the velocity of a cluster is calculated. Using this method, data processing can be up to 20 Hertz. This method makes two assumptions about the environment. First, that the environment is not too cluttered with moving objects, and second, that if there are two objects traveling at similar velocities in close proximity, that they can be considered one obstacle. As you can see in this video, you can easily identify the moving Create, stationary objects, and the laser rangefinder. This video is an output from the velocity tester method. The second method, the Bayesian occupancy filter, also turns the environment into a Cartesian grid. Each space contains occupancy and velocity probabilities and calculates object velocities using both a history step and a prediction step. Initially, grid probabilities are standard and uniform. Data in this method can be processed at up to 10 Hertz. There are both pros and cons to each velocity estimation method. The velocity tester processes data faster, considers the distance of the object in cluster calculations, and tracks the obstacle over multiple time steps. The Bayesian occupancy filter method handles dynamic environments with temporary obstacle occlusions well and takes into account the possibility of multiple velocities for each object. Both methods have assumptions about the environment. Also, the velocity tester does not handle obstacle occlusions well, and the Bayesian occupancy filter has limits to obstacle velocities and can be computationally expensive with large or cluttered environments. At this point in my research, I do not have a conclusive result as to which of the two velocity estimation methods is more robust. In addition to comparing these two velocity estimation methods, I have been developing a more user-friendly control panel for the iRobot Create. Once finished, this program can be used in the future to control the Create without any additional programming.